So now we're going to be using arrays, even creating arrays to organize outcomes. So let's say that we have a four-sided die. It's called a tetrahedron. So it has four sides and it has the numbers 1 through 4 on each of the sides. And let's say that either we roll it twice or we have two of them and we roll them once. And we want to then add or find the sum of those two dice. So we need to create an array to organize all the possible outcomes. So I would start with kind of a table type thing. And the outcomes of the first roll could be 1, 2, 3, or 4. And of the second roll, or of the second die, 1, 2, 3, and 4. And up in the corner, I'm just going to help myself remember what it is that I'm doing by writing the word sum. So when we add 1 and 1, we get 2, 1 plus 2, 1 plus 3, and 1 plus 4. Then 2 plus 1, 2 plus 2, 2 plus 3, 2 plus 4, and so forth. So these would be all the possible sums of rolling the two dice that are four-sided. So now we want to list the sample space. And remember that the sample space is the set of all possible outcomes. And since it's the set of all possible outcomes, we have to start by using set brackets and then listing all the possible outcomes. And as you can see, there's a 2, a sum of 3, 4, and they need to be separated by a comma. They don't have to be in order, but it seems to help most people to be able to see them in order. So those are all that's the set of all possible outcomes, and that is called our sample space. The next thing we might be asked is, are all the outcomes equally likely? Well, as you can see, there's only 1 8 and 1 2 and 4 5s. So we can see that they're not all equally likely. So we would say all outcomes are not equally likely and explain it by saying there's only 1 2 but 4 5s. You could go on to say that there are 2 3s and 3 4s and 3 6s and 2 7s and 1 8. But I think it's good enough to point out that there are not the same number of outcomes for 2 and 5. Now the next question is, how many possibilities are in the array? You might be thinking, well, there's 1, 2, 3, 4, 5, 6, 7, but those are not the possibilities in the array. That's simply how many outcomes there are. The difference is, there are 4 5s, and as an outcome, we don't list those 4 5s separately. But as far as possibilities in the array, a 1 with the first die, if we're going to go ahead and call this set over here the first die. So a 1 with the first die and a 4 with the second die is not the same outcome, it is the same outcome, but it's not the same possibility as a 4 with the first die and a 1 with the second die. And many people want to argue, especially if you use 2 dice of the same color, that they're the same. But imagine if one is red and one is green. Well, a red 4 and a green 1 is different than a red 1 and a green 4. And it's easier to see them as different when you think of them as different colors. So now we understand that as far as how many possibilities in the array, there are 16. Alright, so now let's use the array to help create a probability model listing the theoretical probabilities for each sum. So we're going to scoot this up a little bit so we have some room. And so I've listed each possible outcome, and now I'm going to write in the probability. So there's only 1 2 out of the 16, so 1/16. There are 2 3s, so 2/16. There are 3 4s, so the probability is 3 out of 16. There are 4 5s, so 4/16, and we don't simplify the 2/16 or the 4/16 in the probability model. It's not wrong to, it's just we don't generally do that. So there are 3 6s, so 3/16, 2 7s, so 2/16, and 1 8, so 1 out of 16. And then maybe they ask us some questions using that. For instance, like what's the probability of rolling a sum less than 4? So I would write P in parentheses, sum less than 4. Well, the sums that are less than 4 are simply the 2 and the 3. So there are 3 possible outcomes that would satisfy that probability out of 16. So 3/16. And now if I could simplify that, I would. Well, how about the probability of a sum greater than 4? Well, I look at all of those possibilities, and that's 5, 6, 7, and 8. And so I add all those together. 4 and 3 is 7, plus 2 is 9, plus 1 is 10. So 10/16, and I can simplify that one. So 5/8. You could also write it as a decimal or a percent. And so are these two, just to review something from before, are these two events complementary? And the answer is no, they are not complementary. First of all, you can see that 3/16 plus 10/16 equals 13/16. And complementary events will add up to 1. Also, what we've left out, when it's equal to 4. So in one of these, maybe I could have said, what's the probability that the sum will be no greater than 4? Well, that would be less than or equal to. Or at least 4. That would be greater than or equal to. But in this case, the 2 that I asked for did not include the 4. Well, let's do one more question like you might have to do, which is to predict the number of, let's take the most popular, 5. Let's predict the number of 5s that would be rolled if we were to do, roll 2 dice, let's say 25 times. So in 25 rolls, how many sums of 5? So we use the sum of 5, which is the 4/16, and set up a proportion with how many out of 25. Now if I had chosen 32, that would be a simple scaling. Well, in this case, we're going to need to cross multiply. 4 times 25, that's easy, that's 100. And then 16 times x is 16x. And then, of course, we need to isolate x by undoing the multiplication by 16. And 100 divided by 16 equals 6.25. Since I can't say that 6.25 times I would roll a sum of 5, I would go with approximately 6 times.